Hi guys, welcome to the second part of the hardware and software module for IAL AS Unit 1. Okay, so last week we discussed about, we started the module and we started discussing about different types of hardware and yeah, hi, yes, okay, I'll just wait two minutes more, then can see. Hello, yeah, you can hear me, right? Should be okay, I think. Perfect. Okay. So I just started. Yeah, we just started. So super. So yeah. So welcome to the second class. So last week we started from the first unit of at IAS, the first point. So as you guys know, for IAL, interest and advanced levels, we have two sections. We have AS and AA2 or AL, and under AS we'll be sitting for the exam with two units, so unit 1 and unit 2. So we started unit 1, and also the unit 2 is entirely practical, so it's about building a website and some practical stuff. So the difference between these two is, as I explained before as well, it's about this is more into theory and unit 2 is more into practicals. So ICT, quite easy, straightforward. You just have a simple straightforward paper, and we actually scratch the surface on almost all the hardware components and the details. Okay, so since we started last week about hardware, you all can find the video on YouTube. So the video is publicly published, so this particular video will only be available in the LMS, but you can actually check that as well. And for first time students, I will be sharing this URL so that you all can go and view the video also. Okay, super. So jumping into the table of contents. So this is what we are going to talk about today. So primarily understanding the technologies. So what type of technologies and devices used by this current new generation, and how it impacts the design and the use of devices. So this is what we are going to discuss on this. And then we are talking about a main point called technological convergence. So this technological convergence is a specific phenomenon, I might say, so which basically converged all the technologies together, where we got multiple devices converged into a single device, and it evolved the world into what we are currently living in. So we have multiple devices, and we'll see how what it is. And then need for features and functions. So we'll be learning about the point of, when it comes to hardware, why do we need features and functions, and what type of features and functions which is there in embedded systems or systems. Okay, perfect. So technologies used by digital devices. So now basically digital devices, they all rely on complex systems, right? So they are all connected together, where they do have multiple different complex systems mix and match together, and then they all work as in a simple, like a seamless flow, right? So now example is, we have let's say microprocessors, which acts as brains, and then we have different types of RAM and different types of memory modules, and so on and so forth. So all of these technologies in different devices, they all work in they all are separated into different parts, but they all are now mixed into one, and we have a single structure which is known as technologies used by digital devices, right? So what are the primary devices we have? So we have mobile phones, we have digital displays, we have now, okay, in simple terms, what makes a mobile phone a mobile phone? So you need to have few components, right? You need to have a mobile receiver, so technically GPRS modem, GPS modem. So you should be able to connect to the GPRS network and connect with each other. You need to have a display. Now that's a different technology. You need to have a memory, a capacity to store the data. That's another technology. Nowadays, the camera is also one of the most common and common devices or parts in a phone. So that also required. You need to have a camera also. And then what about the storage? I mean the RAM. So like if you take a typical Android phone or any other phone, you have a massive lot of RAM, because why? Nowadays phones are being used for videography, gaming, and so on and so forth. So for that, we have another multiple technologies connected together, right? So the mobile phone, as you can see it right now, is actually a full blend or a mix of multiple devices, right? Okay, so let's see what this is. Yeah, so these are the custom set of devices which we will be basically talking about. Okay, now we are actually going according to the syllabus, and in the syllabus, in the specification, ICT specification, it specifically asks us to discuss about these points, as well as these are the hardware points which is questioned in the paper. So quick question, Anik, so you are following ICT, right? Or this particular syllabus, or computer science? You
ICT.
ICT, right? Okay, perfect, all good. Did you get the textbook by any chance?
Not yet.
Not yet. Perfect. Okay. I'm also trying to find a soft copy of soft copy of that. So let's see how it goes. Okay. And you will be facing the exam this May, June, or when are you planning to get into the exam?
On May.
May, June, right? Okay. Super. So yeah, so in this particular series, we are actually starting from the beginning. But what I can recommend is just join the revision class as well. So for the revision, I would be basically jumping directly into the unit 2 first. So I will be um, covering up the unit 2 details, because that's the easiest part to cover up at the beginning, and then we'll be starting to do papers after that. Okay, so that's the, yeah, so I recommend you to get into the theory class as well, but these videos will continue. So this is slowly focusing on the theory. Okay, so GPS, most of you know what is GPS is. So GPS is basically the satellite-based system, which is basically revolutionized the way how we interact with digital devices in the world and around us, right? So this will basically help us pinpoint our location, and it will let the device communicate with the satellites, and it will enable us to get location-based services. So there are multiple different types of location-based services, like tracking, GP, navigation, and so on and so forth. So this literally revolutionized the industry, or the computing industry, mobile phones industry, as well as this made a massive impact on the rest of the industries as well, because like shipping lines and whatever the industry which required navigation was introduced by, like, okay, given as a solution by this particular technology, right? So GPS nowadays, there are devices now. Example is the new iPhone actually has a method where you can actually directly communicate with a satellite itself. So that is again a certain type of GPS, but here this case you can actually send a message, not voice, but you can send a SOS message directly through a satellite, and you can receive that message, or that message can be received by a emergency um, support or personnel, and they can actually support your case. Okay, so that's the whole idea behind GPS. So in simple terms, the keywords are GPS, a satellite based navigation system which we use to interact uh, or connect with satellites, right? Perfect. Then we talk about biometrics. So biometrics, again, straightforward, simple stuff. So biometrics use a unique biological traits, right? So what are the biological traits we have? So we have our eyes, we have our voice, facial structure, so your bone, literally your facial bone structure, and your retinal scans, and mainly your fingerprints, right? And so anything, any biological component in your body which can be used as a validation method can be used for biometrics. Okay, so fingerprint scanners, facial recognition, iris, they have always been there, but now these features have been enabled for the general public, because back in the day, iris scanning was actually a massive machine, but now iris scanning has become a small device which you can just use to scan your eyes, or you just go there, you show your face, and your face will be recognized. Right? Now this have been specifically applied in most of the industries, and as you guys know, now that has actually replaced the typical usage of a password. So nowadays, most of the time we use our biometrics to basically authorize payments and so on and so forth. So this eliminated a lot of sub hardware stuff, such as keypads and physical buttons, and like all these type of physical verifications, because it allowed you to automatically validate a person by their biometric details. Okay, so basically the most common biometric example is the face unlock and your thumb unlock on your mobile phones, which basically uses different types of scanners to scan your face structure, and then it would validate and get you in. Then touch screens. Okay, I'm not going to go in depth about touch screens because you know what is a touch screen is, right? So touch screens, basically they replaced the physical buttons and keyboards of devices, and then this becomes, so what happened was, back in the day when we had physical buttons, those were actually bulk devices, right? I'm not sure whether you have seen these old, very old phones. So we had these mobile phones which came in the early 2000s, where the phone was very bulky because of just one reason, because it had a huge keypad. So the keypad had the plastic button, so when you press on it, that goes through a membrane, and the membrane touches the surface of a circuit board. So that circuit board, the membrane, and the keypad makes it huge. Okay. So, but then what happened was, when the touchpad was introduced, everything was removed, and then we just had a flat screen, and that was it. Okay. So this replaced almost all the keyboards and designs, and it allowed us to come up with very interactive, it gave us the opportunity to introduce much more interactive ways to interact with the system. So those days we had to type something in and send the details and then get it processed out. But once the touch screens came out to be, you had the option of just using your finger to get things done, right? So this, so be careful, Anik. You do get questions like this where they ask you just to explain what revolutionized this industry when it comes to touchscreens, or what are the benefits which happened or which introduced when it comes to the release of touch screens likewise. Okay, so those things you just need to make sure, you just need to write the basic stuff, so about why this revolutionized. Then sensors. So sensors sensors were there for a long time, but what happened was with the technology boom and with the miniaturization of the transistors and capacitors and all these hardware items, technologies, I mean sensors, became very tiny. Okay, now back in the day, when it comes to a motion sensor, it was actually a big block of a box. It was a huge box, and that box had a couple of reflective mirrors, including a couple of IR blasters, where it will basically blast it into an area, and if that line gets disturbed, then immediately an alarm or a circuit triggers. Okay, nowadays, so those were huge. Now a motion sensor is kind of like a small, this size, small circuit block which has a sensor, and if you move your hand in front of it, it will break the circuit and give you a feedback. So it will break the circuit, so you just need to connect some sort of an action to that circuit in order for it to work out, right? Okay, so how this got evolved is, now based on this different types of parameters and different types of requirements people got into, these engineers, they made small sensors. So there is motion, light, proximity, temperature, pressure, and all these different devices. And what happened was, they allowed you to get more details in and get more data into the system, which in return gave the option of adding more features to devices, right? So when these devices are getting small, then that means you have a small form factor where you can put more items in. So example is, the best example would be this smartwatches. Okay, so the smartwatches, when they started back, it was like these didn't had any features. So this, I bought the first generation smartwatch when this Apple Watch, when it was released. So it didn't had any features. Now this is the 10th generation version. So here we have like there's about 30-40 features compared to the first version what we had before. So the idea behind this is, yes, almost 10 years, but for that 10 years they actually improved a lot of different components in it. And at the same time, since the hardware and the circuits became smaller and tinier, they were able to add more sensors. So we have sensors like heart rate, light, body temperature, and what do you call it? Yeah, mainly the pressure and so on and so forth. And the blood oxygen is also there in this case. Okay, so those are the ideas behind sensors. Then memory. Memory is actually something straightforward. I hope you guys all know what is memory is. So memory significantly influences a big design and requirement when it comes to digital devices. Okay, so as you guys know now, when something is processed, some data set is processed from the CPU, the CPU temporarily needs to store whatever the data which was processed, right? So when this data is getting saved from the CPU, there has to be a temporary location for the system to put this data, go and put this data, right? where's the temporary available temporary location, obviously that would be put in the memory, right? So when it comes to any sort of a application which is running on a digital device, that also consumes memory, right? RAM, or random access memory. So memory is a completely standalone research factor which is being researched throughout the world by multiple organizations, where they all extremely focus on trying to increase the speed, right? Speed and the performance. So the speed and the performance must be as optimized as much as possible for the system to perform more, right? Okay, so this is kind of like a rat race. Huh? So I'll tell you the reason behind this. Now, when it comes to CPU companies, like the top brands in the world, Intel and AMD, right? Now Apple is also there. Now slowly Qualcomm is also catching up to the race, right? With their Snapdragon CPUs. So anyway, my point is, now when a new CPU is released, when a new CPU architecture is released, what happens is, you tend to build a complete high-end performing system on top of that CPU. So what happens is, there's always going to be memory restrictions, because let's say if the CPU can process up to couple of million data points per second, and then if that data points cannot be stored in a memory location which has some sort of an equivalent power, then we call it as a bottleneck, right? Then there will be hardware bottlenecks which will end up slowing down the system, and you will spend couple of $1,000 or $1,000 කියන්න බෑ, rupees කියන්න බෑනේ, $1,000 on a system, and you will end up having a throttled or bottlenecked application. So that's why memory is getting, so the idea, the technology behind memory is always being specifically researched, because always they try to make sure the memory advancements and capabilities are specifically up to date. Okay, so the definition wise, random access memory is basically acts as the device's short-term memory, and it impacts how quickly it can multitask and run applications. Okay, so while storage, as you can see here, so storage, as you guys know, hardware, hard disks and SSDs, solid state drives, they determines how much data can a device hold. Okay, so these are like two different things. One is focusing on the short-term memory, and the other one is focusing on how much data it can store. So let's jump into that and see what storage is. So in simple terms, storage is the primary digital transformation of the primary reason, or the advancements of storage is the primary reason where we are at currently with this particular technological state. So why do I say that? It has two primary reasons. One is AI, artificial intelligence. This whole AI concept is based on data, right? So now, if we go back to about 10 years ago, we never had a specific set of data to build an AI model like what we have right now. So as you guys know, this if we take OpenAI, ChatGPT, they started building this model back in 2006. Okay, now almost 20 years, right? So almost after 20 years only, they have a solid working data model, and now it is exponentially growing, because now they have achieved one point. Now based on that point, they can grow it. And at the same time, storage is also now getting expanded. Okay, so to tell you guys a fun fact. Now, YouTube is getting videos every day, right? And you know that you can upload any number of videos to YouTube, and it's free. They don't charge you anything. And the size, you can upload videos up to 10-15 gigabytes. Okay, now not 10-15 gigabytes. I think you can upload up to videos up to about 50-60 gigabytes, because usually these lessons, which will span up to about one and a half to 2 hours, that's about 6 gigabytes. Okay, so just think how much cheaper storage has become. Now, YouTube, here a charity service, and YouTube is earning in millions and billions because of their advertisements. But then again, the whole technological revolution began because of our advancements of storage. Okay, so now I hope you get the point. So that's basically the number one factor which influenced all these designs and applications. Then the next most important factor when it comes to software and the advancements, it's battery power. So go back 10, 20 years, we had very, very poor battery performance, right? Nobody was ever thinking of building a sports car, a battery powered sports car, because we never had the technology to store battery or to store power in a portable container, right? So this, for the last few years, batteries and battery performance and the battery capacity have seen an exponential growth, because one reason is because most of the big shot companies are power backing it up, right? Tesla, and now this Chinese company called BYD, and there's like multiple different companies who literally spend millions and millions of dollars in money they invest on trying to learn and improve their different types of batteries. Okay, so that has become a good like a big point, as well as now, because of this improvement of battery technology, now we have lighter, smaller and portable devices. Plus, the best example is, if you get a question like this, like if you get a sometimes you get questions like give an example of how battery innovation impacted the industry or the computing or devices. So the first and most simplest example what I can say is drones. These DJI and these sports and FPV type of drones. So we didn't had drones back in the day, right? Because why? Those we didn't had batteries. We had motors. We had the architecture. We had everything. Remote control was there, and we had drones, but not battery powered drones. If you just do a Google search or a YouTube search, you might be able to find out we had like huge drones which is powered by gasoline. So you have like small gas engines where you have these helicopters powered by gas, something like that. So they were powerful but very noisy. So since it's gas, it has engines, so it was really noisy and huge because it had to carry a big weight, like with all that gasoline and all these engines. So best example is that, right? So increase the new advancements of batteries basically allowed us to come up with this. Then miniaturization. So miniaturization, right? So miniaturization is the next most revolutionized thing happened in the digital industry, because that enabled creation of multiple different types of compact devices. Okay, so example is if you take the iPhone. So an iPhone, what happened was they compressed everything together, and now we are given up with the mixed, like a full mix of activities, things you can do, as well as features and like functions in a small package. So that is the advancements we had with the miniaturization. So advance in component technologies such as microprocessors, memory and sensors that allowed these essential elements to shrink in size. So it allowed them to get small. And then at the same time what happened was they allowed you to go like compress it, and at the same time it was maintaining what they had, not maintaining what they had, right? They were improving their performance. So we, even with the miniaturization, what they do is they add more stuff into it. Example, best example is I hope you guys know the controversial point where Apple removed their headphone jack, right? So people, a lot of people, let's say, uh, came up with bad things for them. So they said it was kind of like a bad thing that they did by removing the um headphone jacks. So they had to go through a lot of criticism. But the thing is, ultimately everybody followed, right? So Samsung criticized them a lot, but after a couple of years, Samsung was like, okay, never mind, we are also going to remove it. Why? They got to know the basic reason. When you remove this, you get more space, because that 3.5 millimeter headphone jack was actually it had a certain size to it, right? So when you remove that, you get more space, which in return you can add more devices to it. Okay, there's a marketing part involved in this as well. I'm not going to talk about that because this is IT marketing part. If you guys want to know, send me a ping. I will I will explain that later on. Okay, so I hope the miniaturization idea is clear. Okay, perfect. Then next is processors. So now we are going in the order. Okay, so we started from RAM, storage, and the whole concept of miniaturization and this sensors and so on and so forth. Now we jump into the final component of processors. So processors, as you can see, processors are called the brains of digital devices, right? So they significantly impact every device's design. Okay, so there are different types of processors. Okay, so that is the first part you just need to keep in mind. So every device has a processor. So the thing is, there are general purpose processors where you will use that for almost everything, like as what you might be currently using your phone or your laptop, which is created in a way so that you can use it for multiple different purposes. Or you will have these type of devices. So this is a this is a pointer device which I use to switch the slides like this. Okay, so here this also has a processor in it, right? But this processor is not like the processor what you can find in your laptop or your phone, because this particular processor is designed to perform a specific activity. Okay, now this has a processor. Okay, just if you take this one, this AC remote, this also has a microcontroller like a processor, which will still perform a certain set of activities. It's more than a more than again it can't run Windows on it, but then again it has some certain features. Now here this case, if you take this one, this has a real-time translator. this particular this small device, it has a laser light as well, so there's a laser and also you have a real-time translator, as well as you have some features in it where you can talk to it, send messages, and so on and so forth. So all of these things got evolved because of the evolution of processors. So when we get faster processors, that means we can perform more activities in it, right? Gaming and multiple thread, multitasking, so on and so forth, video editing, and all sorts of different activities. At the same time, processors are becoming more efficient. So back in the day, when we had a computer, and that computer usually it consumes like couple of 100 watts all the time. So like if you take a core i series, like about which came about 10 years ago, they were like running with the highest TDP 24/7. So that means when you turn on the computer, if the CPU requires 100 watts, that is going to run on 100 watts from the time you turn it on. Okay, but the thing is, nowadays with the new technologies, we do have this concept called E-cores and P-cores. So E-cores means efficiency cores, and P-cores means performance cores. Okay, so these E-cores and P-cores, they allow you to work in a very low performance or low power way. So what it does is, you have this efficiency core. So the efficiency cores are actually there to maintain and keep the active performance. So example, okay, best example is if you take an iPhone. So the iPhone or any other Samsung high level phone, like a flagship phone, you have a certain set of E-cores and you have a certain set of performance cores. So when the phone is locked, and if the phone is just lying on a table, then what it does is it shuts down all the performance cores and it keeps only the efficiency cores online. Okay, so the efficiency cores, what they do is they check for your email, they check if you get a phone call, notifications, and any other background activity. Example is, let's say okay, let's say you're going somewhere and you have Uber on. So that Uber application, even if you lock the screen, that Uber is actually running behind the scenes, right? On the phone itself, the Uber app is working. That's being handled by the efficiency cores. So the efficiency cores doesn't let the application die, it will keep on processing. And why they do this is because to save the battery. So battery performance is one of the most important points when it comes to mobile devices, especially laptops as well. So that is the way they help us to extend the battery life. So at the same time, CPUs evolved into powerhouses as well, because nowadays we do have two different research paths when it comes to CPUs. If you guys are keeping an eye out for this year's CES, so by the time this video is recorded, we just finished CES in US. So just search for CES 2025 and you can see all the tech devices which was released at the CES conference. So they had two different types of researchers. So one was to build high-end CPUs, like NVIDIA demonstrated their Blackwell VGA cards, the 5090 series, the 50 series with the 5090, the AI model where it generates like does some massive next level stuff. And at the same time, AMD presented a new CPU, which is very very memory efficient and power efficient, but at the same time it's extremely powerful. So they call it the AI max chip or something. So likewise, everybody is kind of like showing off their technologies, but the processors, as I said before, there are two avenues. So we do have heavy high-end machines, as well as other way around. We have performance devices, okay, which is focusing on laptops, gaming gear, online gaming. I mean, sorry, mobile gaming, as well as to support different types of online games and all. Okay, so evolve. That's the evolution of the CPUs. Then RFID, so radio frequency identification. So RFID technology has actually significantly impacted the design and use of digital devices. Okay, so we are still we are a bit new for this technology. I mean, we when I say we, I mean Sri Lanka. Okay, Sri Lanka is still a bit new for this technology because there are a lot of restrictions and so on and so forth. So there will be a time which we will be getting this publicly released. But if you take other countries, RFID is something which is being used commonly throughout the normal day of a user. Okay, so example is if you have visited a different country, like let's say if I take Singapore for an example, technically you don't need to take your purse, like you don't need to take your wallet, or a lady doesn't need to take her purse when you're going out, because if you have your phone with you, that's enough. Okay, so you have this concept called Sing Pass, where you can actually load money into their system. So that basically installs a software on the phone, and when you load money into the software, the phone has the RFID feature, no? So you can tap and pay, and all this stuff works with the phone. No? Similar to that, you can pay at any bus stand, any train, any metro, any location where you go in. You can just pay by the card. Okay, that's all about using RFID. So when this RFID system is on, all you need to do is you just go to a location, you get your phone, you tap, and you pay. That's it. Okay, so that significantly changed the design of almost everything. So even you can use this Apple Watch, you can just go there and you can tap and you can pay. Okay, so all of these devices, they use RFID. And nowadays, I think you all might have already noticed Visa, the Visa cards, they released the tap and pay feature in Sri Lanka. Now I think almost all the cards has that. So all you need to do is you just need to tap and go. So you don't need to hand over the card to the whomever the person, where you can just click on it and you can finish it there. Okay, so they allowed us to enable payment features, as well as contactless transactions, as well as it basically followed the path of payments and improved their methods and added more features to them. Okay, so that's the main idea what happened with RFID cards, as well as you got different features like contactless ticketing. Now example is I we have a education platform. So in this platform, we give name tags and cards for all the students, like school children. So they will have to keep that as their ID card, and all you have to do is the class teacher just have to tap on the card, and that's it. And the student is immediately registered, and we get a attendance count. So those type of things, they all evolved because of the evolution of the RFID. Then we have the next feature which is known as NFC. So NFC is something a bit different, where here this works in a short range wireless technology, that is basically impacting devices where you can contact with close range. Okay, so similar to RFID, NFC also works in the same way. This is still communicating between radio, but the thing is it has to be very cheap, very close. So example is now adding a NFC chip into a smartphone or a smartwatch basically allows you to control it in a wireless manner. Okay, and so for example is nowadays the new version of iOS allows you to send the contact details by tapping another phone. So if I want to share my details with you, I can just tap my phone, and if you have an iPhone as well, the data will be immediately transferred. Okay, so NFCs is basically identifying the devices, and it allows you to send close proximity sensors. Okay, so the keyword for this is close proximity. Okay, perfect. And then QR, I think I don't have to explain anything. We have a lot of experiences as Sri Lankans with QR, right? So QR codes, quick response codes, so they made a significant impact on how we interact with digital devices and how we interact with the world around us, right? Because QR, actually the invention of QR is quite interesting, because now, as you know, the entire structure of the world is actually based on data, right? Binary and binary patterns. So the thing is, now when it comes to these type of binary patterns, when we need to have something like a specific way of sharing data. Now binary data, you can't share it, no, you can't keep a pen drive hanging around a location, or you can't keep a CD or something, so that we can't ask people to please install this and load it, right? So technically we didn't had any way of sharing data with others, but this QR, it basically gave us the option to store some data. So technically on a QR code, what you have is ones and zeros. So that's a binary representation. So here this particular block, what you have in this block is literally a binary code, right? So this binary code can be read by using a standard QR reading protocol, which is now has become a world standard. So as long as you can take a picture of something, you can read that protocol. And then in this QR, you have a number of bytes which you can save, and then using this number of bytes, you can actually put a lot of different types of data points into it. Okay, so the QR has few specific points. So this has the square where you have the scannable code, and it has some specific things. We have these squares where it will basically let you find the rotation of it, as well as it will have some version information and the orientation. So sorry, not rotation, it's the orientation. So you can find out which side it is there, and the system will automatically, the reader will automatically knows that okay, this is set into this side, and it will read the data. Okay, that's how QR codes works. Then the next largest technology upgrade was for connectivity. So what happened with the connectivity? Connectivity like Bluetooth, Wi-Fi, and all these network systems, they were influenced massively with all these new technological upgrades. Okay, so example is one of the most one of the most biggest technological updates when it comes to connectivity is Wi-Fi. So Wi-Fi versions got rapidly implemented with the new features. Now the latest Wi-Fi systems are actually extremely fast. I think Wi-Fi 6E or something, which is compared to what we had about 5 years ago. It's about 4-5 times faster. Okay, and then Wi-Fi helped us. So with this fast Wi-Fi, it enables lot of different technological ways where we can interact with systems. Example, okay, so the best example I can say is I bought a long time ago. This was in 2013. I can't remember exactly. I bought a PlayStation. I bought a PlayStation 4 when it was released. Okay, so this PlayStation has had an application called Remote Play. So that was only available for Androids. And those days I had an Android tablet. I had a Samsung Android tablet. And what I did was I installed this software, and I plugged in the PlayStation to my network cable. Okay, so that was directly plugged into the router, and the other side I connected to the Wi-Fi. But I was really frustrated those days because the Wi-Fi technology we had this dialog router and all. That Wi-Fi technology was not speed enough to remote play a game. Okay, so remote play, what it does is you can actually start the PlayStation 4, so PS4, and leave it running. You don't need to plug a TV. So the TV has to be there, but you don't need to turn on the TV. You can remotely connect through Wi-Fi to the PlayStation and then play the game remotely on a external device. So it was really bad back then, but this was almost 12 years ago. Yeah, close to 12 years ago. So about 4 years ago, I bought the PlayStation 4 Pro back again. So I sold my old one and got a PlayStation 4 Pro. And and then I wanted to try that out. And when I tried it out with the new PlayStation, we have a very high-end gaming grade router, Wi-Fi router now. So with that one, now I can play with the full FPS on without any lags or anything. So after almost 10 years now, we are seeing a massive improvement on it. So that is just about gaming, but think when it comes to productivity stuff like companies, offices where they use multiple, let's say, Internet of Things like devices which is interconnected with each other, robots, this wireless robots, wireless cleaning stuff, and anyway now technically everything is connected, right? Because recently I went to I can't remember where I went to this. I think in Golf Face Mall. You have the Singer showroom. So I went to the Singer showroom and I was just browsing around, and then I saw this sticker pasted on a TV saying, sticker on a fridge saying it's a AI powered smart fridge. Okay, so Samsung, some sort of smart fridge. So apparently I just went there and I read the details. So apparently that fridge has a screen, and it is running some sort of a Samsung operating system, and that fridge connects into the Samsung's ecosystem. So technically, if you buy the fridge, and you need to buy a TV and a sound system and the vacuum bot, that room bot thing, and a washing machine and what else? Coffee maker. Okay, so and obviously you need to have a Samsung phone also. So if you have all those things with you, then you can actually connect these things together. Okay, so once these are connected, so once these are all connected together, you can control all these devices from the fridge. Amutu idea. I was also like, since I don't have all those devices, I'm not going to spend money and buy a smart fridge because I'm an Apple guy, so I live in the Apple ecosystem with Macs and so forth. But if you live in the Samsung ecosystem, yes, please do try it out because apparently you can set the air conditioner temperature, you can set the room board, I mean the vacuum cleaner, and all these details from the fridge itself. Okay, so why these features were added to that? It's mainly because of the advancements of connectivity. Whoever thought that you're going to go to your fridge and press some buttons and change the temperature or check if the clothes are washed? So that's the advancements of connectivity. Perfect. I hope up to this extent the point is clear. Okay. Anik, any questions so far? I think you're on mute. Okay. Should if you have any questions. Huh? Okay. Then we jump into the next point, which is known as the technological convergence. So be careful, guys, and also um, uh, pay attention to this because this technological convergence is a main point which is being questioned at. I think I saw almost this question on almost all the papers. Okay, so um, the idea behind technological convergence is getting multiple. Give me 1 second. Yeah, convergence is basically getting different devices, digital devices, integrated together, okay, so that you will get multiple functionalities and technologies as a single independent entity. Okay, so example is, now if you take um, a smartphone. Okay, so the smartphone, ideally we had the phone, right? The phone didn't had any smart features in it, and what happened was then people started adding features. So the phones started to have color screens, and then they started to have the ability to play music, take pictures, take videos, and then this this videos and with the videos and the pictures feature, then we got the option of getting what do you call it, internet, right? So the browsers were there, and then ultimately games also came in. Ultimately, we got the smartphone with all these features added together. Okay, so let's learn about the technological convergence and how this um, evolved into the current technology what we use. So integrations of functionalities. So this is the point. So converged devices, it basically combines features. It's like, let's say in this case, communication, messaging, media consumption, information access, internet browsing, and also productivity, document editing, and even health monitoring, right? So that is part of the fitness tracking and the heart rate monitoring into one specific device, right? So everything is converged into one device, and that way you can use it. So that's the point which I told you about my Apple Watch. So this is also a single device which has everything in it. right? So this is a good example of a technological convergence. By the way, last year's paper, we have a question showing a smartwatch which I think 4 marks. I think it's a 4 mark question as far as I remember. It asked in that question they asked um, what are the what is technological convergence and how that improved the smartwatch and what are the features the smartwatches have um, compared to the compared to those individual devices. Okay, so keep this in mind. There was a question. Nah? Okay, so driving forces. So for the technology convergence, as we discussed before, the driving forces is primarily the miniaturization of electric components, right? So as people, as the computer scientists find out different ways of miniaturization, different devices, they give you much more features to push in and uh, connect with each other. Example is what I can show you is okay. So if you guys have seen this ECGs where films are where people lie in the hospital on the hospital bed with some sensors plugged into the chest, right? So that particular thing, Apple came up with the same thing, where in here you can see this is the so here you can see a metal ring if and then couple of sensors, right? So this metal ring, this is actually four electrodes, standalone electrodes, and this is the sorry, this is two electrodes and this is the third one. So if I when I run this, all I need to do is I need to start the heart rate and I just need to touch this digital crown, right? When I touch the crown, the circuit completes and it starts tracking my heart rate. And the fun part is this particular sensor is being approved by the American Heart Association, certifying that this output is accurate. Okay, so that's kind of crazy, right? So crazy to know, right? Like how a small watch can produce an accurate result similar to that huge machine you have at hospitals where you put in all these sensors and things and you go through. Right? So that's the main idea. So primarily driving forces are miniaturization of the components. And then benefits, we have a massive lot of benefits, right? Primarily, this converged devices offer convenience, right? And portability. And මැරෙන්න නැතුව ඉන්න පුළුවන්. හදිසියෙ මැරෙන්න යනවා නම් මේකෙන් කියනවා මැරෙන්න යනවා බෙහෙතක් ගන්න. Right? So lot of benefits. And at the same time, they allow they actually reduce the usage of single devices. So back then, now like if you take okay, example is if you go back about close to about 20 years, we had we needed to have multiple devices to do multiple activities. So example is to send an email, you needed to have a computer, right? To take a photo, you need to have a camera, a bulky camera, and to take a printout, you need to have a printer. Plus, if you want to if you want to take a photocopy, you need to have a photocopy printer, right? Photocopier, and likewise, it had so everything was divided into or split into their own components, not actually split. Everything was performed using their own individual components itself, right? But now with the convergence, that basically went away. Now, if you take your phone, you can send emails, you can take calls, you can not we can't send fax right now, but you can take pictures, you can send it to someone else, you can process pictures, edit videos, take videos. Nowadays, with the new AI stuff, you can animate stuff, animate videos, generate content, generate AI content, massive list of things if we talked about it, right? So that's the benefit. Then, yeah, this is what I just explained. And yeah, don't worry about the sound. Okay, so then the challenges. Okay. Pause this. Yeah, okay. So then the challenges. So when it comes to the challenges, the converged devices actually introduce new complexities into the day-to-day life of people, right? So example is now, um, as they offer new features, at the same time they add additional complexity as well. Okay, I'll give you the best example now. That fridge I told you about, that smart fridge. Now just think, if you have that smart fridge at your home, and let's say if your grandmother or your grandfather walks into the fridge, how are you going to tell him to use that fridge? It's going to be extremely complex for that person, right? You'll have to tell him how to use it, how to open it, how to touch the screen, what to touch in the screen, how to read it, how to understand what is there in the screen, and so on and so forth. So that now that in their point of view, if you look at what that convergence made to the fridge from a typical consumer's point of view, it's a bit of a complex thing, right? Because now for them, the refrigerator is something where you keep food, where you put food and you keep it there. It's kept cool or chilled so that uh, it won't like get bad or rot, right? So it will just maintain the current state as much as possible since it's chilled or kept in a cool place. But nobody expects you to set the room temperature from the fridge. No? That's the next complexity. Then okay. Now that's a whole different thing, but that's something you can learn. But this is the next most important point: the privacy. So this is a massive issue now in Sri Lanka. Yes, we don't have that much of privacy laws as of right now at this date. Okay, so we don't have that much of privacy laws. But then again, now there are devices which continuously capture and gather our personal information. Okay, so these devices, they can actually expose your personal information, and there can be chances where your information can be leaked. Okay, so obviously they store vast amount of data, and then in return there can be privacy issues. Okay, and also now the next most important point, since we have so many components connected, if one component fails, everything goes off. Okay, now example is now okay, this is actually one of the major reasons I still haven't bought a electric vehicle. So I know I am using couple of vehicles. I do have couple of vehicles, and my primary one is a Jeep, and I do have a very old van as well, which is a 1987 model. Okay, technically it's my age. Okay, now that thing, if it doesn't start, you can literally open up the hood and look at the engine and figure out something. Okay, you can if it doesn't cranks up, you can find out what has happened to it. At least you can guess. So I have a Jeep which is a 2022 model. So in that one also, it's hard. So something happens, there's no way you can find out exactly what it is. So you can kind of play around with it and see, but you have a big information display, you can't find out anything. But then again, still you can give a call to a repairman and they can come and find. But let's say if you have a Tesla, now in the morning you go out, you get into the car and you press start, and nothing happens. Okay, now what? Now that's going to be a problem, right? That's going to be a very, very scary problem, because if we live in US or the UK or any other place where they have Tesla, like Tesla mechanics and Tesla official agents, then that's perfectly fine. If something happens, then yes, it doesn't turn on, give a call to them, they come and they take the vehicle, they fix it and they bring it back. Here, what? So I don't know. It's their personal preference, but I feel really sorry about all the people who are driving Teslas in Sri Lanka, because technically still we don't have a proper service personnel who does those services. But now these other companies like BYD and there are some companies which officially came to Sri Lanka. No? Now I am also considering of buying an electric car, because now there's an official company who backs that brand. So if something happens, still I'm okay, because shape pege I can see that there can be something or someone who will assist me to fix this. Okay, so that's the challenges. So if one goes down, the entire thing is dead. Okay, so that's the challenges when it comes to converged devices. So yeah, so so this is what I just explained. So the technology convergence literally um, reshaped the entire landscape of digital devices, and it basically blurred the line between the traditional categories such as like phones, cameras, and computers. Now, actually, we don't have three different things, right? Every phone is a computer which has a camera. So nowadays, cameras also technically like computers, but they do have a lot of much more high-end features. So this trend is expected to continue, obviously, as the technology advances, leading to more and more high performance stuff, right? So for the consumers, this technology convergence offers very good features and versatility, because it allows us to consume, allows us to use more high-end features, right? But the problem is, however, it also presents a set of challenges in terms of the complexities, as I told you about the point with the fridge. So it does add some complexities, but end of the day, it would help you a lot to make your life much easier. Okay, so in finally, to wrap up this point, in broader context, technological convergence is basically transforming industries and shaping the way we interact with the technology, as it opens up new features and innovations and creativity, so that people can Im- increase their potential and obviously be more creative and help the society more. Okay, then we jump into the final point. Okay, so here we talk about embedded systems. Now, embedded systems. Okay, so what is an embedded system? Embedded systems are specifically a specific computer, okay, designed to perform a dedicated functionality within a system. Okay, so the definition is embedded systems are specialized computer systems designed to perform dedicated functions within a larger mechanical or electrical system. Guys, don't worry about the slides. These slides will be uploaded in the LMS, so you should be able to access it from there and download the details. Huh? I don't want you to take notes in this particular section, because this is all about basic theories. But we will be taking notes after we jump into the rest of the modules, where we have some features and points which we need to talk about. Okay, now, okay, so embedded systems. the idea is this, and then we'll see what it is. So the primary idea behind an embedded system is to make sure that it's single functionality. Okay. Now, good example is an air condition. So air conditions, they do have one task, right? Just to maintain the temperature and a certain small set of functionalities. So here the example is like if it is like controlling a microwave oven or controlling a car's engine, or let's say some sort of a medical device. So that all focus on one single activity. So why do we need this? So embedded systems are actually mainly focused to work on real-time operations. Okay, it's like this. Now I'll explain this in a very simple, different way where you can understand. Now, if you take Microsoft Windows, okay. Now let's say you have a. I think you guys might have seen in those in movies and some places where you have this shock machine where if some person's heart is not working, you use this and you shock them, right? So giving them a shock will automatically jilt their heart and will get them back to life, right? Okay, so now that particular machine has only one specific purpose, right? You charge, you check, you hit them, and they get the charge. They get hit with the whatever the electricity, and it does the purpose, right? It triggers the heart, right? Charge, hit, do it, and done. Okay, so that's the flow, right? Now think, so that's the only purpose of that operating system. That device. Now think if that device is running on Windows, Microsoft Windows. මරු වැඩේනේ වෙන්නේ. දැන් ඔන්න ලෙඩෙක් එනවා. ලෙඩා ඇවිල්ලා ඕක තියෙනවා. ඔන්න මේ suddenly you get a message saying Microsoft Windows is updating. Leda, right? Or you can you charge it and you hit and you get a message saying, sorry, system is loading. Or please wait until the system is started. Right? That cannot be happening, right? So since this is very mission critical, so that has to be instantly done. It needs to be reliable, right? That is why we work with embedded systems. So this embedded system will only perform one activity and it will be basically selected to run or to do only that activity itself. So example is an airbag deployment system in a car, which needs to react in milliseconds, right? When a crash happens, it has to burst and pop the airbags in less than a millisecond, because otherwise the person or the driver might get critical injuries, right? So let's say if Microsoft Windows or some sort of an operating system is running the deployment system, nobody, it won't react in a split second time, right? So I hope you guys got the idea. So that's the whole idea behind the one action at a time, or the real-time operation concept. Then limited resources. So embedded systems typically have limited processing power, memory and storage compared to general purpose devices. So just one activity, so you don't need 10 gigabytes of memory, or you don't need 100 gigabytes of storage. It's just some specific small activity. You get it done and then done. That's it, right? So this will reduce the cost drastically and it will allow you to make sure the design is compact, right? So example is, okay, so I'm using this DJI mic. So if I open this up, you can see this particular device. This is a studio grade mic which has a 24-bit output, and this has a 16 GB internal storage which we can record into the device also. Okay, now see the size of this. It's just about 1.5 inches, and it's just my size of my thumb. Okay, so that's the thing. So this is again falls under the category of a embedded device, because it it serves and it's created to perform only one purpose. Here in this case, capture the sound, record, transmit, done deal. Okay, so because of that reason, limited resources, so it automatically makes it smaller. And reliable and durability. So this is also one of the most important things, because embedded systems often operates in harsh environments, something like inside a car where you have all these vibrations and so on and so forth, as well as it can be like outside. So let's say if you take a CCTV camera, the camera system, that also falls under the category of an embedded system, end of the day, right? So they are intended to be outside the weather, so you get damaged by rain and so on and so forth. So all of these are basically created to handle the reliability and durability. Then software hardware integration. So this is the most important thing when it comes to embedded systems, because embedded systems, they don't have multiple activities in them, no? So it's just to perform one specific activity at a time, right? So for that, you don't need to have a massive operating system running in the device. All you need to do is you need to have a processor which will execute some sort of an action, and you just need a few lines of code to perform whatever the specific action you need. That's it. Simple as that. So let's say if you create a small system to check the light condition outside and to turn on a light, then that particular operating system, that particular device should need the software only to handle that particular action, right? Some sort of a light sensor has to be there, so it senses the light and turns on the light. Done deal. That's it. So because of this reason, you can actually come up with custom software so that it will achieve their intended functions. Then we'll talk about the essential functions of a system. So primarily essential function is embedded systems often control physical processes, right? So embedded systems are actually mainly there to run some physical activities, like to perform like to move a robotic arm, or to adjust something, or to control motor speed, or to control the AC temperature and something like that. Okay, so these are the primary essentials. So controlling is one, and then we do have embedded systems for monitoring. So monitoring is also one more thing where it monitors the environmental conditions. Okay, so in this case it can be single system parameter, it can work as system parameters, which will basically send the user the feedback immediately as it happens. So example is we have this water level monitors around the world, which we call as buoy sensors, buoy sensors, right? So those are like single kind of boyawa killer. So those are like big, kind of like a cone, kind of like a thing which floats on water, and it has a kind of like a self-sustaining battery operation system where it charges the battery with the movement of the water, and as well as some has solar panels, and that each and every buoy is actually connected to a satellite network which sends the variability of the water at that location. So if by any chance if a tsunami is coming, there will be a massive variation of the water height, right? Then using that, people used to predict and create weather monitoring. So now those things are all sensors, and now even if you take that type of a sensor, you cannot run an open system in it, right? Its whole purpose is to perform a single small activity, right? So that's the way it works. Then we use for communication, as I explained in that example. Communication is also one more thing, so that device will get the whatever the activity which is happening and will communicate it back to a home base, to a satellite service, and from the satellite it will be communicated back to the location where it will track things. Then signal processing. So this is also one thing which signal processing allows us to process signals from sensors such as images, sounds, vibrations, and it will also allow you to extract meaningful information. Okay, so this will basically allow you to get the details out, and it will allow you to extract information in different points. Okay, to tell you an example for this, just think the point which I just said, that that boy has the water height sensor. So that is basically a couple of sensors which will basically check the vibrations and the what's the word for that? High vibrations and the elevation, right? The shift of the elevation. So if there's a sudden shift, then you can check the range it got changed, and then from that you can predict. And then obviously data logging. So whatever the data which is being saved up, it's getting logged and it's getting sent out. So this way, embedded systems can record data over time, which can be then used later for analysis, diagnostics, and performance optimizations. So this will basically let us see, or let us have a clear view about what is exactly going on. And okay, so then the next point is the need for embedded systems. What's the need? So primarily we need embedded systems if we are focusing on making products in a specific way, where to make them smarter and to more efficient and user friendly, right? So when it comes to embedded systems, they basically gave a lot more improved functionality, which basically allowed you to give more smarter solutions, as well as automation and frequency. So embedded systems basically allowed you to automate tasks and reduce the human error. Now example is in this video, as you can see. Give me 1 second. It's mute. Okay, so as you can see here, we have a circuit system which is trying to we have a robot in part of a factory which is basically trying to solder some circuit items to it, right? So these type of things, technically and physically, people can do, but not this efficiently, right? Yes, obviously you can solder a circuit, but it's going to take a long time. Nobody's going to put the soldering like this, right? So, and obviously when a human does this, there is a massive chance of doing an error, right? Having some sort of error in the soldering part, so that then that will reduce the productivity. So then the next point is cost reduction. So cost reduction is also, as I discussed before, since these points are moved into different components, the overall cost is drastically reduced, right? So then you don't sense you don't need high-end machines. All you need is something small which will basically interact and work at that point, and that's it. So overall cost of the product will obviously go down. And safety and reliability, that's also uh, very critical, as I explained you with that heart rate, that heart thing. So for when it comes to embedded systems, you know that it's very safe and reliable, because there is no such thing as updates and it's going to work in a while or nothing like that. Either it works or not. If it doesn't work, it doesn't work, then you have to fix it. Because it is designed to perform only one activity now. So if that activity cannot be performed, then it's done. Okay, so that's how it works. And then innovation. So innovation also plays a big role in this, because with the new innovation of new services and new products and services, it basically drives a massive technological advancements across all the industries, because that is how this um, because that reduces the cost primarily. It tends to let people innovate and get more features in. Okay, and then examples for embedded systems. It's primarily consumer electronics and automotive systems, industrial automation, and medical devices, as well as aerospace. Okay, so these are the primary points of the type of embedded systems can be used. So please do put this down. I think we'll be discussing this while we went through when we go through the revision as well. But then again, these are the primary points which you need to keep in mind and remember at the end. So what's next? So the next is we'll be discussing during the next class about firmware, performance, file size, and the binary conversions. Okay, so the binary conversions, be ready to do some mathematical calculations, because we will be talking. So in this case, for this AAS, we don't go in depth into binary calculations. Okay, so all the things which you learn during your IGCSEs is more than enough, because we talk about few factors on how these calculations are made, and there are some calculations when it comes to binary, denary, and byte calculations here and there, right? So you get 2 questions in the paper, so we just need to make sure that we nail them. Okay, super. That's a wrap for today's class. So this video will be available in the LMS, and remember to watch the previous video as well. And and catch you back at the next class.